Hello there, welcome to question 7 of our physics exam preparation series. In this case, we'll be looking at Coulomb's law as well as its applications. Let us look at the context as well as the first 3 questions. Here you go. Alright, so in the first question, we're asked to state Coulomb's law in words. Okay, and this is exactly what is expected. The magnitude of the electrostatic force exerted by one point charge on another is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance between them. Okay, so that takes care of 7.1. So remember, the charge M is suspended from the ceiling and charge N is vertically below charge M. So in other words, if you're given charge N to be a positively charged object or sphere, it will make charge M to be negatively charged. That answers question 7.2, because if it does not move vertically down, it means there is a force of attraction between sphere M and sphere N. Alright, so that takes care of 7.2. In 7.3, what are we asked to do? We are asked to draw a free body diagram for sphere N. What is happening? Because an object, it's matter, it will definitely have some sort of weight, or we can label it as the gravitational force, which is always vertically downwards. And there will be a force or an electrostatic force, if you use the words from the law itself, that is going upwards, because sphere N is obviously attracting N to itself. Right, so this takes care of the first 3 questions. Let us look at 7.4, where some calculations are needed. Alright, so in this question, we're asked to calculate the magnitude of the charge on sphere M, right? So that is our only unknown. What is known? We know the distance between the 2 spheres, or the centers of the 2 spheres, is 0.3 meters, and the charge on N is positive 8.6 times 10 to the power negative 8 coulombs. We have our constant, and the keywords that comes from the context itself, that charge N hangs stationary, implies that the net force acting on charge N or sphere N is equal to 0 newtons. Okay, in other words, between the 2 spheres M and N, there is no net force. Actually, the forces are at equilibrium. Okay, what are we looking for? The charge on sphere M. Do we have the mass of sphere N? Yes, and that is it. So now we just plug in everything into this equation, where we are saying that the net force, from our previous question, we said we have 2 forces acting on sphere N. So it will be our electrostatic force towards M minus the gravitational force going down. Okay, and by substitution here, this is the direct application of the equation of Coulomb's law, minus, what is this? Mass times gravitational acceleration, which represents the gravitational force. And if you do the mathematics there, you end up with the charge on sphere M to be 2.32 times 10 to the power negative 6 coulombs. All right, remember the equation gives you the magnitude, not the sign, whether it's positive or negative. But we did say in the previous questions that the sphere M will have a negative charge. Right, great stuff. So this takes care of question 7.4. Let us now move on to the next question. Alright, so for 7.5, there are 2 sub-questions there, and we are asked to compare. How does the force exerted by sphere M on N compare in terms of magnitude and direction? Obviously here, in terms of magnitude, they'll be equal. And that reminds us of what? Newton's third law. Okay? In terms of direction, this sphere is negatively charged and that sphere is positively charged. So what will happen? M will attract N upwards while N attracts M downwards. And that interaction is called attraction, right? Electrostatic force of attraction. So this takes care of question 7.5. Let us go to the last question, 7.6, and see what needs to happen there. Right, so in this question, we need to calculate the net electric field at point X. So what do we need to know? The distance between X and M, which is 0.4, and the distance between X and N, which is 0.1. Okay, we have the equation that we can use here, and we just plug in our values from the previous results and also the information items in the context to ensure that we get to the final answer. So just ensure that your calculator skills are effective there and you're able to arrive here at 53,100 newtons per coulomb. Okay, you'll notice that I chose up as positive, so that influences the way in which you will order the terms there in the equation. Great stuff. So this takes care of question 7, right? I'll see you in the next video where we're going to talk about some electric circuits. That will be question 8, right? Keep well, keep working, and achieve excellence.